outside out of their classrooms and into the area that they live in order to help them connect to what's going on around them. And I'd like to just take another momentary pause to acknowledge the land that I live on and also the land that we're learning about today, the traditional territories of the Wendat, the Onondaga, and the Mississauga, and recognize the enduring presence of all First Nations, Inuit, and Métis people. I'm going to frame my session in a what, now, so what, now what format. So what I'm going to try to do is demonstrate place-based methods that are applicable to urban green spaces by sharing with you some strategies and best practices for how to undertake ecological field studies in an urban environment. I'm hoping that by highlighting some of the stressors that degrade ecosystem function and sharing with you some activities you can do to help students investigate them. I encourage you to collaborate with colleagues so that we can all better utilize outdoor spaces for learning. That's not ambitious in 40 minutes. An ecological field studies program, I always think the field studies are the most alluring part. It's the part that is the most memorable. It's the part that most people enjoy. And it is the part where the most opportunities exist. So I think of that like the inside of a sandwich, the middle of a sandwich, a really good sandwich. You can customize what you want, what you need, and what you prefer in the middle. But it's best when it's held together by some really tasty bread. And that's your preparation and your follow-up. So I will be going through information very quickly. I had a couple of interactive activities that I'm hesitating to use for the shortness of time. So if we have time, I'll go back to those at the end. I will be sharing some resources. Sanya will be putting a link in at the end so that you have an opportunity to access some of these resources that I've created. So again, the whole goal is to maximize our fieldwork opportunity. If you're going to take students outside, especially in an urban environment for ecological field studies, you want to be prepared. So do your research. This often takes the most amount of time, and it's a requirement to access as many diverse sources of information as you can to come up with ideas for how to help students learn about what you want them to learn about. So connecting all of those sources and activities. After you've done your research, it's time to get organized and decide what your focus is. So I did a quick look at the Ontario curriculum, and there are all kinds of opportunities and lenses with which you can get students out to do ecological field studies. I'm sharing with you strategies that I predominantly use for our grade 8 water systems program using the Toronto Ravines as a backdrop. But I'm hoping that the activities that I share with you can generate ideas or examples of things you can pick and choose from to use for a number of different lenses. Once you have your focus, you need to collate your research, revise it, and finalize what your plan is. At the Toronto Urban Studies Centre, we tend to be very ambitious and try to do a lot of things in one day. So in that true, genuine form, I'm going to try to do a lot of things in this 50-minute presentation. So it's a bit of a breakneck pace. But again, I have included my Twitter handle and my email. You can always reach out to me for further information or questions if we get cut off. And after you've done your research and you're organized, it's time to create what you're going to do with students, because we want students to have a purpose. You want to really encourage them to see and hear and do things outside. You want them to engage in it. And of course, the ultimate goal in preparing for field work is that they can do their learning outside and away from the school. As I mentioned, pardon me, this is a grade 8 connected program. So some of the things I will be demonstrating to you are certainly like higher orders of math, but things can be modified, like I said. Pardon me. And I've made this chart just quickly of some quick topics from each grade from 2 to 8. For example, in Ontario, that could easily lend itself to using some of these activities and taking students outside. The program that we do is called live streaming, which is very confusing in a virtual environment. I know, because it sounds like I'm live streaming, but the program name was changed to live streaming a few years ago. And we take grade students to the Taylor Creek and the Ravine to uncover what is happening here from an ecological perspective. And with the changes to learning this year, we have been taking students out, not virtually, but in person, into green spaces also near their school. So you don't have to put students on TTC and buses and take them far away to have access to green spaces. Always encourage you to maximize the space that students are around. How we do this in this particular program is with hands-on investigations and having students find evidence of what's going on from an ecological perspective using observations, data, studying things, and of course, inquiry. A little bit of background about the Taylor-Massey Creek. It is a 16-kilometer tributary to the Don River. So the yellow section you see there is the 16-kilometer tributary to the Don River system. The original headwaters for the Taylor-Massey Creek were diverted when they widened the 401. So now the headwaters starts at a stormwater outfall just south of the 401. It is one of the most contaminated waterways in all of Canada. It exists entirely in an urban setting. 18 hectares, so approximately 18 football fields of surface from the 401 feeds the headwater. So whatever's being wiped off of 18 football fields from the 401 is where this headwaters is. A third of this creek has been placed in concrete channels, and other sections are constrained by something called gabion baskets, and I will talk about those a bit later. And some other parts run through pipes underground. Stormwater outflows flow directly into this creek without any filtration. The industrial land contamination, there used to be factories along this creek, and there's also a lot of landfills nearby. So the leaching and stuff that would happen to that would be a contributor of this, making it one of the most contaminated waterways. The water from the Taylor-Massey Creek contributes 5% of the overall flow to the Don River, but in certain stormwater surges, it can contribute up to 80% of the population in the lower Don River. So what? So why do we need to learn about this? I think that slide spoke for itself, but in Toronto, ravines represent the majority of natural areas in most urban environments. I was just on the session with Stuart Livingston and Mark Cadet, and they were saying that in a lot of urban areas, the green spaces are less desired spaces. It tends to be on slopes, things like that, which is part of the reason why the ravines are still green, and also to mitigate flooding. But why do we need to learn about it? These green areas and these ravines are important to the wildlife and also to the community. Like I said, it mitigates flood. That's actually why the city started to protect these lands about 60 years ago after Hurricane Hazel. They help control erosion. They help mitigate climate change. They clean the air. They help clean the water. They're areas for pollination. They serve as wildlife habitat. And of course, they provide cultural services, recreational opportunities, mental health spaces. So it is important that students and people know that these green spaces exist and how to get to them, how to access them. And they serve, like I said, as green infrastructure to help serve urban and climate problems, and providing all kinds of other things as well. As I mentioned, we look at this ravine area with our students in a lot of different lenses, and I tend to prefer to start with the history. This is actually a pre-visit activity, so we send it to students ahead of time before they do the fieldwork, because that's part of that preparation. When students understand a space, they tend to want to learn about it more. I just want to give a caveat that at the Toronto Urban Studies Centre, because we can do a program a number of times, and we have staff who really like creating resources, some of our stuff I don't want you to feel you have to create something necessarily of this level to engage your students. The history lens helps you investigate the land from a succession of things that have happened. So for us, to get students to engage in history, we've done a matching timeline activity. This is the answer key, but the students see all of these word clues and they go through a series of sections of the timeline specific to the Taylor-Massey Creek, and they match the words to it. It really engages the students. That idea of matching, looking at the images and utilizing the language to support it, really engages with learners on different levels. So I am not going to take the time to go through this, but I do want to just sort of show you. It acknowledges the Indigenous presence along the way. It demonstrates the estimations of population at different times. And as the story continues, it starts to highlight the impact. So at the top, you can see what is the impact of industrial sites on the Don River? Well, water pollution, fish disruption, increased water temperature, erosion. Why did cholera outbreak happen? Drinking dirty water. So we try to start introducing some of the concepts that are important to having the ecological perspective of the land. And we encourage students, of course, to do something with that learning, because so what? We get them to do something with it, and we encourage them to make tweets for each section of the timeline to try to summarize what's happening over the time. So here are some examples of some that have been done over the years. We also like to look at the area from a geographical point of view, and we also do this pre-visit again, so that before the students arrive to this space that they're going to be exploring, they have a general understanding of the history and the geography of the land, so they can better apply that knowledge. So for the geography activity, we focus on concepts of population, the numbers of wetlands, industrial sites, tree cover over a period of time on the geography, and how that affects to climate. And so again, we do a matching activity. So this one I was going to do an outbreak session for, but I just don't feel we have the time for that. So we have again laid out Toronto over time. And when we're with the students in person, those little images at the top are actually loose, and the students look at the chart below and put the images where they belong. It's a very large document, so I've had to spread it over two slides. But you can see that it shows the population of Toronto over time and how it really peaks recently. It shows wetlands, of course, increasing after the ice age and steep decline, and how industrial sites just were absent until recent time periods, and how the industrial times coincide with the drop in tree cover. So we encourage students to make observations about all 5 of these trends, and then again, getting them to collate what's happening in each of these time periods. And for this, we get them to make hashtags. So it's a way to engage brains in different way to apply your knowledge. So water and trees brings people. Time period 3, some people, but no industry. Time period 4, more people here now. And number 5, my thing is in the way. I can't read it, so you'll have to read it. So this gives you an idea of the kinds of activities that we do. And I was going to have you engage in hashtagging. So that was what the activity was for us. These kinds of things lay the groundwork to maximize the fieldwork portion of the learning. So a couple of things, and I know a lot of you are professionals that do this, so please excuse if this is repetitive for you, but some things that need to be considered, in my opinion, when you engage in field work with learners is, of course, number 1, safety, bringing a first aid kit with you wherever you go, making sure you communicate with the appropriate people, the time it starts and ends, and exactly where they need to be at those times, so that if there's a problem, people can be found. We have students work in small groups together. Usually we have found that groups of 4 is ideal, but they often work in partners within that group of 4. So it allows for students of different abilities and learning challenges or expressive abilities to rely on one another and collaborate. Please encourage them to bring water. And I am always careful to make sure that I review what might seem obvious to me, but might not be obvious to everyone. And that is like the protocols of being in outdoor green spaces in a city. They are highly trafficked by pedestrians and cyclists and dogs, and students need to know how to behave on that, how to be on the right-hand side, how to move, how to look. But it sounds silly, but if you don't go over it, you get a lot of ringing bells and angry people. And of course, always plan for the unexpected. Off-leash dogs are often something that students sometimes have to contend with. So making sure you have a plan in place and articulating to students what they do so that they can feel safe while they are out doing field work. Other considerations are accessibility. So ravines in the Toronto area are classically down a steep hill. So you'll need to make considerations about access. I always encourage people to go and with their own feet and their own bodies, go and look at the space you're taking students to for accessibility. In the outdoor education department of the TDSB, we actually have an all-terrain wheelchair we can access when necessary, which has been very helpful. Keeping an eye to the weather. Not even students, like adults, people often are not quite prepared for the weather. So having extra things with you. And I find if we're asking students to record things, their hands often get cold. So a couple pairs of like mini gloves in your backpack can go a long way. Washrooms can be an issue. When we go down into this particular area, the washrooms are way up the hill and they aren't always open. So we have to go through the city and find out. So there's a lot of logistics sometimes with washrooms. So keep an eye on that. If there's a cost for transportation, if there's any way to mitigate that to increase accessibility. If there's any devices being included, making sure that they're charged and bringing spare batteries. And of course, are they allowed to snack? When can they snack? What are the responsibilities of snacking? And so on. Finally, your materials for urban fieldwork. Make sure that everything you ask students to do feeds your focus, that everything can be transported on their backs or in their hands, and that you give them somewhere to record their observations. In my opinion, students should not be asked to explore an area without having some option to record what they see, because it taxes the working memory to have to go and look at all these things and then come back to your school and remember them all, especially when you're being asked to apply it to greater learning. There should be some option available for students. At Tusk, we like to think we've got the perfect solution. I'm not sure that it is, but I do believe in it. They are plastic clipboards. We have them in a variety of colors. So usually one group will all have the same colored clipboard. It helps from a management point of view, just for quick, oh, there's that group, the red group's over there, just in your own head, or, oh, why is there 2 yellow clipboards with that group? Where are the other 2 yellow clipboards? Like, it helps with management. It's got a hole in it, so we put an elastic through to hold the paper in place, and we attach a string. We actually use a drill with a very small drill bit to drill through pencils and put the string through there as well. It works very well in light rain and in incidents, because you can just dry out the paper and the pencil is still there. And in heavier rain, you can slide the clipboard into a large Ziploc bag and students are still able to write. So we have found it to be very useful. Always include a map. If you're asking a group of 4 students to go do something and look at places, they should have a map. It increases navigation skills and sense of place. Time, as you can tell, I'm racing against it, but trying to give your students enough time to do what you've asked them to do and to dress comfortably. Let's go check out some fieldwork stuff. I went down there in person to get a few videos, because of course I can't be there right now with the stay-at-home order.
Hi, welcome to the Taylor Massey Creek. I'd like to show you around in person, but we're going to do the best we can virtually. Lots to learn, lots to see, certainly lots to explore. Let's go check it out.
So behind me, you can see what are called gabion baskets. Those are human-made wire cages filled with rocks, designed to hold the stream in place, to hold the shoreline in place. So I mentioned those earlier, so I wanted just to focus that off to you. We often start our activity with something physical and introducing the concept of surface runoff. So that introduces concepts like pollution, accumulation, surface types, water quality. So we try to get students moving. Now, again, I don't have a group of students that I can have demonstrate this, so I've created it for you to see. We do this activity where there's a bit of a gradual slope, and we ask the students to imagine that the bottom of the slope is into a water source. So I put a bucket there or some sort of container there to signify that. And the students know that they will be acting as water droplets traveling across this land, making their way to the water. And we give them each a card, and they sort of run down 1 or 2 at a time, calling out what their water droplet has come into contact with on their way to the water source. And so by having them call out what they come into contact with, students start getting a better exposure to the kinds of things that can go into our waterways from surface runoff. In a way of, so what? We ask them to sort themselves based on what they called out into things that are human generated, into things that are naturally occurring things. And then we ask them to regroup things that you think can be dealt with, things that could be corrected or improved versus things that are damaged. We ask them to come up. So those, we ask them to apply what they've just done through this reasonably active game. Another lens to look at a green space of any sort. You can do this perfect for schoolyards and everything. I took my own children down because they're in my family and I can go outside with them. That's actually my daughter scootering in the background. And I did the soil compaction activity with them. So you'll definitely hear in my voice that I am teaching my children what to do. So I have a very, very short video. Anytime you see the red heart, that indicates roughly where we did this experiment. So it's all about impervious surfaces and the infiltration of water on urban surfaces. So here it goes.
So the first step is to make sure you have all the materials and you fill up your cup with water. So you need about a half a cup. And then the person who pours the half a cup is going to pour it into the cookie cutter that the other person holds tight, and they start the timer. Ready, go. And we see how long it takes. Pour the whole thing right in. There you go. And we just wait and see how long it takes for the ground to drink up the water.
So that took just over 50 seconds. We moved into the forested area.
There you go.
So that took just under 14 seconds. And then we went to the human created trail.
It's not going anywhere. So, is it absorbed yet? It's been a minute and a half almost. No. Okay, checking in at 2 minutes. There's still water in that cookie cutter? Yep.
My young kids are absent at 2.5 minutes.
We're over 3 minutes. Is there still water souped around? Yep. Okay, so it kind of really just spread out, but didn't really go down much, did it?
It's a really good activity to have students do. They really get into it. And again, the idea of the timer and pouring the water and holding, so giving jobs and a sense of purpose to all students involved. So again, so what? So we ask questions. Where was it best? Where was it worst? Now take a look around. Take an estimate. How much of the land do you think is each of these types? And then we always leave them with questions, and they don't have to do this when they're outside in the field, but it uses what they've done in the field to keep the conversation and the learning going. Another lens that we sometimes look through, see how I'm doing on time, is the waste and pollution, the waste and the pollution lens. And this one's it's a big topic. We're trying to introduce concepts of point and non-point points of solution, impervious surfaces, stormwater, sewage, pesticides, fertilizers, road salt, sediments. So we're trying to cover a lot of things. So we do it from a diversity of activities, a memory game. We do a CSO game. I'll explain what that is in a moment. They do a photo hunt and so on. So again, So I'm kind of glad I have a mask on because it's very smelly and I know you can hear this sound behind me. So let's go investigate behind me and see what the smell is all about. There are major spots in the Taylor Creek area that there is a very obvious smell that you cannot avoid. Students, oh, what is that? So it needs to be taught about. And this comes down to introducing the concepts of waste systems. All urbanized places, all municipalities have to deal with waste. And that system of waste they come up with will act one way in dry weather and another way in wet weather, depending on the type of system they have. So most places in Toronto now are on a separate sewer system. So that means that water that so on dry weather, it's no problem. Your human waste makes its way into a totally separate pipe and it gets cleaned. And there's no problem because the weather is dry. And in wet weather, it often functions in the same way. Water coming down downspouts and storm drains gets rerouted and diverted, like I said earlier, directly into the creek. So it is not filtered and clean. So what your water comes into contact with on roads and sidewalks is important. But this particular part of the city, as well as a few others, is still on what is called a combined sewer system, CSO, combined sewer outfall, it's called. So in dry weather, it functions fine because, again, the sewage makes its way into this combined pipe and goes for cleaning. But when you have storm water surges, the two sources of waste mix in the tunnel. And if there is too much for the system to handle, it overflows as a mix directly into the creek. This is hence the statistics at the beginning why 80% of the pollution in the lower Don can be attributed to the Taylor Creek, even though it's only 5% of the water flow, because there is sometimes raw sewage mixed right in with stormwater waste and dumped right into the river. So especially in the spring, it happens more often. So we engage this learning with, again, an activity. We want to engage students in our learning. So we have 4 different kinds of containers. They're little like pencil cases because we keep everything small. And inside those pencil cases are a variety and a number of different colored, usually poker chips or something to indicate different colors. And the bags are indicated what they are. They might be storm water like the cloud, or they might be one of 3 different kinds of urban infrastructures. So we ask students to stand by one of these bags. They're given a couple of instructions. And when they're called, they know how many of these poker chips they need to take with them into the main pipe. So we have a line or something on the ground. And then there's usually the teacher who's visiting takes the student, hands them 1 poker chip at a time, and they have to say 1, 2, 3, 1, 2, 3. So it's a slower process, and that's to imitate filtration into the water treatment center. So this is a great activity. The students understand, like, it takes time to clean things out and they're waiting. And sometimes when your weight builds up, indicating a surge, we divert some of the students from the line and have them drop their chips on something that later they find out is the river or the creek and the overflow. So this is a modification of a game we got from Project Wet called Super Bowl Surge. Then we have a chance to go and look at what all of the different colors of poker chips represent. I had a teacher tell a story once about how they had purchased a store that used to be a photo development store, and they were renting the storefront. And when they went to the basement, there were big barrels of chemicals that would have been used from the photo development time period. And so they let their landlord know that these need to be disposed of before they can open their business. And they went there one evening and the light was on in the basement. So they went down to the basement and they found the owners pouring it down the sewage drain. So these chemicals have a risk of going directly into our waterways. So these are the kinds of stories and the kinds of concepts that the students are exposed to. And then we equip them to go check it out, but they have to know what to look for. So again, this is often good pre-visit activities. We give them, and I just put this photo here to show you how we keep things condensed. We love page protectors because it keeps things dry. But you can also put two together and fold it, and you can see there's little Velcro labels underneath all of these photos, and you open it up and there's the labels for what these things are. And again, the students use their observations and they find out what these things are and what they mean. So they're engaging in it. And this is sort of what it looks like in process. They can test themselves. Okay, what's this a picture of again? What's this a picture of again? And we have access to a memory game that I made where they have to match the picture to the title of what they're seeing. So again, these are good in-school activities as well. But if you're taking them in the field, this is an old CD case holder thing we found, and it folds right up to something nice and small. Then, of course, go look with your own eyes. What can you find in terms of pollution? Look, write down what you see and record it with a picture. So for example, for this photograph, students are seeing a point source of pollution, something they can identify where it comes from. It's a road, and it would have road salt spread on it in the winter. So this is, it goes over the creek and the water. You can see that maybe those sort of tubes, and then there's, I'm not being very clear, there's like a basket. So the water is being pushed into that down the tubes that make their way right onto the ground right beside the creek. So you know that there's higher salinity in the water in this area. This is another example of pollution. This is a non-point. You don't know what's been mixed in or whose house or where it's come from, but this is a combined sewer outflow. That's near where I was standing when I said it was pretty smelly. And on this particular day, it's pretty dry, but they have the grate there to catch larger things. Here's just another example, non-point. It's a sanitary sewer access. They see a lot of them. So students, they love this. They get out, they're looking for things, they're writing it down. And again, they're working in groups and they have a number of different jobs because we've also given them a map where they can indicate where they saw these things. So at the end, they're going back to school with photographs, a record of what they've seen and where they saw it so that they can continue their learning. So your field work is where they use their observations, and the before and after is where they connect it beyond that. So again, what pollution sources are most concerning? Because students have been told that the Taylor Creek leads into the Don River, which leads to Lake Ontario, which is where our water comes from. And you give them an opportunity to come up with their own ideas of how could this be addressed. We also introduce concepts of erosion and erosion control. So how do sediments get transported and deposited? This goes back to non-point points of solution. And we introduce the idea of riparian zones, which is green plants and things serving as a filter. So again, this is a lot to cover, so we do it in a number of ways. The first thing we do is we play a game. And again, I don't have the students here, so I made this for you. We try to do this on a slope of land and let them know that the bottom represents water. So usually there's maybe a tarp there or just a bag and a line for a river, or if you can use something naturally occurring, that's even better, like a rill or a gully in the ground. And I have spread out popsicle sticks of different colors. And then I ask most of the students to be plants, and they stand with their arms out, and one foot has to stay anchored and they can pivot all the way around. And they're basically going to be tagging the water droplets that make their way through as they're picking up these popsicle sticks. Now, if they're tagged, and most of them are tagged on the way down, they have to drop the particles that they have collected at the roots of these plants. So at the end of the simulation, you see that there's all these popsicle sticks deposited at the base of these plants, which of course use their roots to drink up the water and purify water. And you see that some get through, and then this is where you tell them what the colors mean. So brown is naturally occurring. Sedimentation and erosion and moving sediments through the water is a naturally occurring thing. The problem lies when the pollution also gets through and enters into our waterway. We do the same activity a second time where we switch the roles, but instead of being plants, the students are asked to be rocks, and they crouch down and they can't do anything. So the water droplets make their way through, and of course it's almost a clear, straight clear out, other than what the rocks might have been standing on. And you can see the river also got wider, because when water can flow uninterrupted without plants, it has more velocity and it erodes and it widens the rivers and it takes everything with it to the water source. So again, this introduces concepts of erosion, and we again send this as a pre-visit, and we talk about what are signs of erosion. What can you see? What can you expect to see that demonstrate what erosion is? So we've actually created these images, the ones that are on the right-hand side, to help serve as not just a photograph, but also some sort of like more cleared out drawing. And what are some signs that the city is trying to control the erosion, that they're trying to minimize the risks of erosion? So when students have an opportunity to be familiar with all these things, we have them play a game that I made called Spot It. You might have heard of it. I went to a website and I gave each photograph a letter, A, B, C, D, E, F, G, and then I typed in all the letters, and then they showed me what each card should look like based on letters. And then I went and made them moving the photos in. But basically, students are given a card and they find another student and they reveal, and they're in a race to find out which photograph do we have in common, because any one card is only going to have one thing in common with another photo, and whoever calls it out and can name it first, so this is a photograph of plant diversity, they would win. They acquire the card. So you can have them just like shake hands and move on, or you can play it like an entourage, where the person who wins gets the card of the person who did not win, and the person who did not win is now cheering for the person who won to beat the next person. And you end up, it becomes a very fun game. So here's another example. So erosion is the match, and on the top and the bottom, it was undercut. So when you empower students to understand these things and play games with it, it really makes them better able to go and look for it and record what they see and take pictures. So here's an example of erosion. This is an unstable bank. Now, you might also see other signs of erosion here, and this is why it's important to let students write down what they are talking about for each picture, because when you come to look at this picture again later, you're like, oh, or was I talking about deadfall, or what? Empower them to feel confident with their choices. So here's another example of erosion in terms of deadfall, all the branches piled up in the river. And here again are those gabion baskets. This is the city's attempt to control erosion. Unfortunately, a sign of erosion is also failed gabion baskets. And there are parts here where you can just see these things have been completely gutted and are actually contributing further to the problem. And again, they have a map to document these things on, but they're working in a group of 4. So you've divided up the work so that they're all invested in the activities, and they have a lot of things to take back to school with them. And you get them thinking, so what kinds of problems can erosion cause? How can they be addressed? We do a tree canopy study, measuring the tree crown, and this is engaging, like I said, math at a grade 8 level. So, pardon me, we've actually created we've chosen an area, a study area, and identified the trees in it that we want them to study. So we've done 6 trees in this particular area. And then in their small group, students are given soil thermometers, and they're also given measuring tapes. We do a demonstration, and then they're off on their own. So they find whichever tree they've been assigned to, T1, T2, whatever it is, and they look up to try to find the furthest branch out, and they try to measure from the base of the tree out to the furthest branch out, and they record that number. Now, they also put their soil thermometer in the shade, and they record that as well. And then the theory is they can move on and just gather the data from the other students' spot. So everybody should have the same data, but they've done the measurement once and then access to the data from everywhere else. And then if you have time in the field, they can do this, or they go back to school and work on the math. And I love this because it's living math. Students often go, oh, math. But then when it's a tree that they've measured in an area that they see, I have never seen students grumble. They get their cell phones or calculators out and they get to work. So A equals pi r squared, and they find out that this particular tree, the shade provides an area of shade of 18.1 meters squared. So they add up all 6 of them to get their tree canopy total. They do an area study, so 30 times 45. They do a simple math and find out that these 6 trees in this area provide 12% tree cover. And of course, they would have also done soil temperatures. I had my kids do it that day, and even on just a normal spring day, there was a 3-degree temperature difference between the thermometer we put in the sun and the thermometer we put in the shade. So again, there's all kinds of information and questions and learning that can come from that. And I find students are very invested in it because of the active learning option. We also engage in some water quality testing. You don't always need a lot of equipment to do water quality testing. We focus on temperature, pH, turbidity, and velocity, but there are all kinds of things like dissolved oxygen you can do as well. So here's an example of some of our stuff spread out. We can use, you don't need a lot of space, you don't need a lot of stuff. And again, students have clipboards, so they can do their thing. So the creek temperature the day I was there was 10 degrees, and that's within the optimal value. And we again, so what? So we give them some things to think about. How does, higher water temperature impact water quality and so on. You can see that the pH was also within the optimal value. We did do dissolved oxygen that day, but I took it out of our thing. The dissolved oxygen the day that I did it was very, very low. This is a photo of water I took from the stream. I would be lying if I didn't admit that I did give it a shake before the photograph, but you want the students to look, like to take a sample of water, or you get a sample of water, and to have them look with their eyes, or to look at the river. What do you see? Oh, it's murky. There's lots of floaty bits. It looks dirty. Whatever observations they make by looking are excellent. Looking is the best way to make an assessment. And then you also give them something, either a microscope or a hand lens, to look more closely. We also let them engage in water velocity testing. This is really fun. We give them either pine cones, or the day that my colleague and I did it, we found little sticks, and we wanted to assess what we thought the water speed was for this particular creek on this particular day.
3. Mine got a head start.
So mine's the one on the left, hers is on the right.
It still isn't going to beat yours.
I'm not going to do anything.
So it's a good opportunity for students to learn
Mine's
that,
not going anywhere.
that in one creek on the same day at the same spot, that water travels in different speeds. And we always send videos back to the students, or when it's virtual, we obviously share it with them, about this exact same spot in the river where I've taken videos over different seasons. Because after a storm, the water is just surging down this river. And, in the fall or after a lot of dry weather, it's really quite low. And this is sort of on the shallower end. So students get a lot from just dropping that stick and watching it. And so what does that mean? Well, what could happen if it all of a sudden increased? What would happen to this shoreline? What would happen to the plants? What would happen if it decreased? And getting them thinking about these things. Other options of things that you can engage your students in green spaces for learning is biodiversity studies. We do a grade 6 program on biodiversity, where students are using observations as well as tallies and different ways of knowing to assess biodiversity. Invasive species we also do this, we do an activity on this in High Park, but teaching students what invasive species are, like basically there's native and there's non-native, but what's the difference between non-native plants that are invasive, and what kind of damage does that cause? I put the asterisk there because I was very excited on Thursday to listen to Mayor Tory's talk about on Earth Day about what the plans were for the city, and it was all about ravines and investing money in the City of Toronto ravine health and combating invasive species and addressing what needs to go on in there. Pond and stream studies we do in different programs as well, looking at invertebrates specifically. There are all kinds of ways you can include students in a green space, engaging in community stewardship activities. Having students tally is a phenomenal thing to do. One group of students are tallying the number of trees in your neighborhood park, while another group of students tally the number of cars that go by in a X amount of time. Somebody else tallies the number of different things they see in the grass. And then you can put this together, and your students can start to get a sense of what's in their park and what should they do instead, or what do they think would be better. Solo sits, I strongly encourage, especially throughout the seasons. If you've got a green space near your school or your, go have the students sit there for 3 minutes in the fall, and then do it again in the winter, do it again in the spring, and encourage them to go in the summer and see what they observe about their spaces. So like I said, they do a lot during the field work, and I think it's prudent that you give students an opportunity, where am I at for time, to make connections to what they see, apply the learning they've done. And that's why you've had them write things down. See if they can relate it to somewhere beyond just the Taylor Creek that we took them to, or just the park around the corner. Look at maps, look at bigger places, look at bigger spaces. How does what you learned apply? Let them generate ideas to investigate. Have them create something with what they've done. Use their photographs, explain what they've learned, make up a game, make up your own game. We did those games about erosion and we did those games about combined sewer. Maybe you could make up your own game to help somebody understand what you saw. Maybe you could write a story or create some art about what moved you in that location. How could we create an opportunity to engage in stewardship and taking action? And of course, you want to culminate both your own, like looking back on what you've accomplished, but also asking students to culminate what they've learned. So think back on what I should spread that over 3 lessons. You know, I should cut this in favor of this. I should send this ahead of time. Making your changes as needed. And again, if you take your students out in a green space, especially in a city, but anywhere, you have done a good job and congratulations. With all of this, again, I have an activity, but I'm going to skip it. You want to give students the opportunity to make connections. So pick a couple of topics and explain how they're connected. So how are humans connected to erosion? How is runoff connected to soil temperature? Whatever, you let them try to make as many connections as they can. I also like to give them a blank map of the area and let them design. What do you think if this was blank and we could do whatever we wanted? How could we best take care of this ravine land? Build a dream ravine. And I've also just recently started working on one of these cause and consequence charts. So looking at 6 things that we know cause changes in the built and the natural environment. How many of these 6 things have a number of stressors in them, and letting students start to do their thinking and talking. So like I said, hearing John Tory the other day was promising. At least I'm always happy when I see ecological things in the mainstream media, because it gives me a bit of hope that I'm not totally alone. Maybe somebody is hearing. And just 1 week ago today, the Globe posted a great article about a ravine land who's who. Take a virtual hike through our urban ecosystem and the threats from humans. And there was a whole entire artistic representation through it. It is beautiful. These links will be included with what's shared at the end. So don't worry. I know they're not clickable on the screen. There's a great documentary made about 4 or 5 years ago called Accidental Parkland, and it is about the Toronto ravine system and how this parkland was mostly an accident and how it needs to be preserved. Costs less than $3 to rent it on Vimeo. So now what? What do I want from this? What do I hope for you? I hope that you can go safely and purposely outside to explore these urban green spaces, engage with the community, try to help students build connection with what's around them, and it might even inspire them to take action. Support others and yourself in getting outside, but don't take my word for it. With all that's going on with COVID, I was able to bring the students whose schools were within walking distance down to this particular creek in the fall. And a student came up to me and said some of the most moving things, and I recorded his voice and I put this out on my Twitter handle.
I think this is like the best thing we did this year, because everything like from this year everything went bad. But after this, taking pictures with my friends, hanging out, it's like the best experience.
This child said to me, and this was in October, I have tears in my eyes, shivers in my body. What he actually said to me authentically before I asked if I could record him speaking, he came up to me and he said, "Miss, I have to tell you, I have to thank you so much. This is the first time I've got outside. Everything is so bad. Everything is so bad. And this is the best thing." And sometimes just letting students take pictures and walk around with their friends and make observations can be what you need. I have another video of students talking, but I think I'll save the time for space. So thank you so much for attending this session. And if there are any questions, I'm happy to answer them to the best of my ability. I don't know if there was anything that came up along the way. I know it's a lot of information very quick.
Yeah, I don't see anything in the chat box. So if you got the, if you got the link for the.
Yes, Sonia does. I think she'll put
Perfect,
that.
thank you, okay.
Thanks. So for this particular program that I showed you highlights from, that was a grade 8 program, but I really feel strongly that you can take students out in any grade and have them see a green space in a meaningful way. And that a lot of the activities I've shared could be modified or altered. Really something as simple as like tallies or counting or sitting quietly. But again, my pedagogical belief is that you need to provide students with a place to record what they're thinking about and what they're seeing so that they can do something with it. Now, not every student needs to write something down. And that's why you need to provide a lot of options.
There was a question about community partners.
Sorry, I'm just seeing them now. Community partners. We do this on our own. This is Toronto Urban Studies Center. So we're taking TDSB students out, and we mostly communicate with the teachers. So we take them out to do this work, and then we communicate and support the teachers on how to make further extensions and connections within their specific communities. So I mean, listen, I'd like 50 more people to work at Tusk so we could do all these things, but we're doing what we can with what we've got. If there's questions in there, Sonia or Sheila, can you let me know?
Yeah, I think we're just about out of time.
How close do I let students get good questions? Accessing the water at Taylor Massey Creek is actually quite difficult. Okay, so no, students don't actually access the water for the water quality testing. My colleague and I, we do that. We collect the water and bring it out. No, because they really shouldn't be. Hand sanitizer is your friend, unfortunately, for accessing the Taylor Massey Creek water.
Yeah. So I'm just aware of the time here because the next session is in 10 minutes. So on behalf of the Econ Committee, I want to thank you, Kathleen, for an amazing presentation. I